Hi guys, today we're going to be doing student handout 4. This is a lesson called Subtracting Integers with the Algorithm. Today we're going to be talking about using the additive inverse to be able to subtract integers. So go ahead and get this handout out and follow along. When a number and its opposite, go ahead and fill that in on your paper, are added, the sum will be 0. So if we have 7 plus negative 7, the answer to that problem is 0. Because of this property, it allows us to rewrite problems involving subtraction as an addition problem. So when we're subtracting integers, we're going to be rewriting our problem using the additive inverse, and that's going to help us to use our addition rules to solve these kind of math problems. So the additive inverse is like adding a 0 pair with counters. So if we have the problem 2 minus 3, we really use the additive inverse property to think of this as 2 plus a negative 3. This helps us to identify whether our signs are the same or different to help us know whether we're going to be adding our numbers together or subtracting them to get the solution. So the other kind of subtracting integers problem we can have is one of these 3 examples. So sometimes we need to rewrite the problem in order to add its opposite, then follow the rules for adding integers in order to solve the problem. So this example here, 6 minus 7, they used the additive inverse property and said this really is 6 plus a negative 7. When we're talking about integers, we really need to get in the habit of training ourselves to think that this minus sign really isn't necessarily a minus sign, it's the value of the integer after it. So we can really think of this as 6 plus and then that negative 7 instead of minus 7. So then we just use the addition rules or algorithm, and we think to ourselves, 6 plus negative 7, are my signs the same or are they different? And in this case, they're different. When our signs are different, we subtract and keep the sign of the greater magnitude. So I have negative 7 and 6. Well, negative 7 has a greater absolute value, meaning it's farther away from 0. So what I'll do in this example is subtract 7 minus 6, and my answer will be negative because there's more negatives than there are positives. So it would be negative 1. In this example, we have negative 9 minus 11. They use the additive inverse property to turn this into an addition problem. So it becomes negative 9 plus negative 11. Now I just use my addition rules. Are my signs the same or different? When I look, I see my signs are both negative. So I know when my signs are the same, I add and keep the sign. So my answer will be negative, and 11 plus 9 is 20. So I get negative 20. Now here we have a different type of math problem. We have basically a double negative. This says negative 3 minus a negative 8. Whenever we have a minus a negative, you'll see that there's 2 subtraction signs right next to each other. And here is the only way that we can connect them. Minus a negative is really the same as saying add these 2 things together. They cancel each other out. So we connect those 2 minus signs together and we create a plus sign. This really becomes negative 3 plus 8. And then we just follow our rules for adding integers. When I look at negative 3 plus 8, I see my signs are different. When they're different, I subtract and keep the sign of the greater magnitude. Positive 8 has a greater magnitude or absolute value than negative 3. So I'm going to subtract 8 minus 3, and in this case, I will get a positive 5. So let's use our understanding of this additive inverse property to rewrite these math problems. All they want us to do is just rewrite the problems. They don't want us to solve them. So when I look at A, I have negative 5 minus 9. To rewrite this using the additive inverse, or basically to rewrite it as an addition sentence, I would say negative 5 plus negative 9. For B, I would put 8 minus a negative 3. That would be the same as saying 8 plus 3. This minus a negative, these two combine together, and become a plus sign. 2 minus a negative 10, again, our minus and negative, these cancel each other out, and we create a plus sign. So the additive inverse would say 2 plus 10. And in example D, I have negative 13 minus a negative 7. The minus and negative, those cancel each other out, and we end up with a positive. So to write this in the additive inverse, I would say negative 13 plus 7, and then I would follow the rules for addition on all of these problems. So now let's take this information. It says, practice subtracting integers by rewriting the problem using the additive inverse. So first we have to rewrite the problem using the additive inverse. That's the first direction. And second, it says find the sum of each column, checking your answer with the provided sum. So let's do 2 columns together, and then you're going to do 2 on your own. Let's start over here with A. So I have 9 minus 6, and if I follow the directions and rewrite the problem using the additive inverse, I get 9 plus a negative 6. Now I just follow my rules for adding integers. I see that my signs are different, so I know that I'm going to subtract and keep the sign of the greater magnitude. In this case, that's 9. So 9 minus 6 equals 3, positive 3. Second one is 4 minus 7. If I rewrite that using the additive inverse, it's really 4 plus negative 7. I see that my signs are different, so I'm going to subtract and keep the sign of the greater magnitude. So negative 7 is further away from 0. It has a greater absolute value, so I know my answer will be negative. Always important for us to keep our signs. 7 minus 4 is 3, so I get a negative 3. And negative 7 minus 12, rewriting that using the additive inverse is negative 7 plus a negative 12. Now I follow the rules for addition. I see that my signs are the same. So when my signs are the same, I add and keep the sign. So negative 7 plus a negative 12 is a negative 19. So the directions tell us after we've solved these, we add them up together. And if we did these correctly, I should get the sum negative 19. So let's check our work. 3 plus negative 3. My signs are different, so I'm going to subtract and keep the sign of the greater magnitude. Well, 3 minus 3 is 0. So I get 0. I'm going to take 0, the sum from here, and I'm going to add it to negative 19. 0 plus negative 19 is negative 19. These two are the same. They match up, so I'm going to give myself a smiley face because I know I did my work correctly. Now let's skip over here to row C. And we'll solve row C together, and then you're going to do B and D on your own. So with row C, the first question is negative 11 minus 5. If I rewrite that using the additive inverse, I get negative 11 plus a negative 5. I see that my signs are the same, so I'm going to add and keep that negative sign. So I would get negative 16. The second question is negative 5 minus a negative 8. When we have that double negative, we know we combine them. They cancel each other out and they make a positive. So negative 5 plus 8, I see my signs are different. So I'm going to subtract and keep the sign of the greater magnitude. The greater magnitude is positive. So 8 minus 5, and that's going to end up being a positive 3. And the last one, 11 minus a negative 5. Rewriting that with the additive inverse property, those minus and negative, I combine them together. And now this 5 is no longer a negative, it becomes a positive. So 11 plus 5, our signs are the same. We're going to add and keep the sign. I get 16. So now I'm going to add these together and see what I get. So I see right here I have opposites, negative 16 and 16. When I add negative 16 plus 16, I get 0. And 0 plus 3 equals 3. And it told me my sum should equal 3. So now what I want you to do is pause the video. I want you to go and solve row B and figure out if you got the same sum. And then I want you to solve row D and check and see if you got the correct sum. Then come back and check your work. So let's go ahead and check row B. So I see 7 minus a negative 3. If I rewrite this using the additive inverse property, my minus a negative becomes a positive. My signs then are the same, so I'm just going to add and keep the sign. 7 plus 3 equals 10. Letter B, second one, I have 1 minus a negative 9. The minus and negative cancel each other out with the additive inverse property. My negative 9 becomes a positive, and 1 plus 9 equals 10. Last one in this row, 2 minus 6. Rewriting that using the additive inverse property is 2 plus negative 6. If I look at my signs, I'm going to follow the rules for addition. My signs are different. When they're different, I'm going to subtract and keep the sign of the greater magnitude, which in this case is negative 6. So I know my answer is going to be negative. So negative 6, I'm going to take away 2 from that. I'm going to, 6 minus 2 is negative 4. Now I'm going to check my work. So 10 plus 10 is 20, and 20 plus negative 4, my signs are different. I'm going to subtract and keep the sign of the greater magnitude, which is the positive. So 20 minus 4 equals 16. So I'm going to give myself a smiley face. In row D, I have negative 6 minus a negative 8. My minus a negative, that becomes a positive. So this becomes negative 6 plus 8. My signs are different, so I'm going to subtract and keep the sign of the greater magnitude. In that case, it's the 8. So 8 minus 6 is a positive 2. 3 minus 9, I'm going to rewrite that as 3 plus a negative 9. Now I'm going to follow my rules for addition. So I see my signs are different. When they're different, I'm going to subtract and keep the sign of the greater magnitude, which is a negative 9. So my answer will be negative, and 9 minus 3 is 6. So my answer is negative 6 because I have more negatives than I have positives. Last one in this set is negative 10 minus a negative 5. The minus a negative, I combine these two negatives together. I'm going to create a plus sign. So this really becomes negative 10 plus 5. My signs are different, so I'm going to follow the rules for addition, and I'm going to subtract and keep the sign of the greater magnitude. In this case, it's a negative 10, so my answer will be negative, and 10 minus 5 is a negative 5. Now I need to add them up and see if I got this correct sum. So negative 5 plus a negative 6 is a negative 11. Negative 11 plus 2, my signs are different. I'm going to subtract and keep the sign of the greater magnitude. So negative 11, I know my answer will be negative. 11 minus 2 is 9, so I got negative 9, and negative 9 is the answer that they got, so they match. So now let's flip it over and do a couple word problems here on the back. So number 1 says that Taylor has $27 in his checking account. He then writes a check for $35. What is the new balance of Taylor's bank account? Write and solve an equation to represent the situation. So a couple of things to think about here is first that you might not know what it means when somebody writes a check. It's not as often something that happens today that used to happen often when I was younger. So if you have money in your bank account and you want to pay a bill, one way to be able to do that or to pay somebody else money is to write a check. And whenever you write a check, what happens is money comes out of your account to pay somebody else for a service. So whenever we're writing a check, that's taking money out of our bank account. And that has a negative impact on the amount of money we have in there. So this would create a negative integer when we're thinking about creating a number sentence. So just as some information to have as we're going into this problem. So now we've read the problem. Now we're going to go back through and we are going to underline the important parts of our question. So this says Taylor has $27 in his checking account. We're going to underline that. And then he writes a check for $35. So I need to underline that. Those are our two key pieces of information that tell us what our integers are and what is happening with them. The question that they're asking us is to tell or figure out what is the new balance of Taylor's bank account. So now let's go through and lay out our math problem using our 4-step process. So I know that he has, or Taylor has, $27 in his checking account. So So we're going to say Taylor has $27 in his account. That's the first thing I know. The second thing I know is that he wrote a check for $35. This means that he spent money. And so this 35 is really going to be a negative. So this is going to be negative $35 because when we spend money, that's a subtraction. We're taking money out of our account. So now we're going to go to the second box and we're going to read our question to see what do we need to know? What are we figuring out? So what we need to know, what it's asking us is what is the new, and we've underlined this. We got to get in the habit of ensuring we underline what it's asking. Helps us to go back and clarify our thoughts. So what is the new balance of Taylor's account? That's what we're figuring out. Now that he spent some money, how much money does he have left? What is the new balance of Taylor's, that should say account. So now we're going to go to the third box. We're going to plan it out. We're going to write out our equation, and then we're going to solve it. So we know that Taylor started with a positive $27 in his checking account. And then we know that he wrote a check for $35. So when I write a check, that's subtracting money from my account. So I'm subtracting $35 from the account. Now I need to solve this to figure out what Taylor has left. So if I use the additive inverse property, this is really the same as saying 27 plus a negative 35. So now I look at this and follow the rules for addition. So my signs are different. When they're different, I'm going to subtract and keep the sign of the greater magnitude. In this case, he's going to have a negative account balance, which we don't want in the real world. We don't want to have a negative account balance. That means we owe more money. We borrowed money that we didn't have in our bank account. And we don't want to get into that habit because Taylor's not going to be very happy when he finds out that he has a negative account balance in his bank. He can't go and buy anything else because he doesn't have any money in there. So 27 is less than the negative 35. So we know our answer is going to be negative. Now we just subtract 35 and we're going to take 27 from that. And when we do, we get negative 8. This means that Taylor has negative $8 in his bank account. He's going to have to deposit $8 just to get back to zero. So he's going to have to deposit money to pay back the bank. Now we're going to write a complete sentence to answer our word problem question. So Taylor's new account balance is negative $8. We always make sure we put a period to end our statement. All right, let's go on to problem number 2. It says at the beginning of the day, the temperature is negative 11 degrees Fahrenheit. So let's underline that. It seems to be an important thing that we're going to need to use. As the sun comes out, it warms up to a high of 13 degrees Fahrenheit. So let's underline that. It warms to a high of 13 degrees Fahrenheit. And this question is asking, what is the difference in the temperature throughout the day? Write and solve an equation to represent the situation. So when it's asking the difference in temperature, it means how many degrees are there from negative 11 to negative 13. This is asking for the distance. How far away is it? So this can't be a negative number. Distance can never be a negative number. So when we set this up, we really are adding together these two numbers, the negative 11 to 13. So I'm going to show you how to do that in a way that you'll be actually adding and not subtracting. And I'll also show you a way to draw it. So we know that the beginning temperature, and I'm going to abbreviate that, was negative 11 degrees Fahrenheit. We also know the ending temperature was 13 degrees Fahrenheit. And what we're trying to figure out is the difference in temperature throughout the day. So mathematically what we're saying is we ended at 13. How far is it from 13 to negative 11? And in order to do that, we would say here's the ending temperature, 13, and we're going to subtract a negative 11 from it to figure out how far is it from here to here. When we minus a negative, remember that we connect those two negatives together and create a plus sign. So 13 plus 11, our signs are the same, so we're going to add and keep our sign. We get 24 degrees Fahrenheit. So I'm sure you're wondering, well, how did you get that? So let me show you a picture to illustrate how we figured this out. So I'm going to draw a little number line on the side, and I'm going to start it all the way down here at the temperature where our day began. So this is going to be negative 11 degrees. Somewhere up toward the middle, as the day wore on and it got warmer, the temperature started rising. It went up. At some point it hit 0, but it kept going on and on and on and on, all the way up till the high temperature of 13. So when this is asking the difference in temperature, I have to figure out how far is it from here to here. And again, we said that's distant, so it can't be negative. So to figure it out, I would say how far is it from negative 11 to 0? How many spaces are there? And that's 11. And then to get from 0 to 13, that's 13 spaces. So I just added these two numbers together in order to figure out the temperature changed by 24 degrees that day. That's all we're doing, is figuring out how far did it change. And now we're going to write this in a complete sentence. We're going to say the temperature changed 24 degrees Fahrenheit throughout the day. So remember, when it's difference, we are doing the additive inverse. We're finding the distance in the case of this problem. Let's go down here toward the bottom and look at number 3. The directions say use your understanding of the additive inverse and subtracting integers to answer questions 3 through 5. Use the hints to write the name of the student who found the missing number above the box. So we have some math problems here and some little clues down below, so we need to figure these out. So the first thing that I would do before reading the clues is solve these problems using our knowledge of the additive inverse and subtracting integers. So negative 8 minus 17, rewritten using the additive inverse property, is really negative 8 plus a negative 17. When I look at these, I see my signs are the same, so I'm going to add and keep that negative sign, and I get a negative 25. In this next problem, I see 6 minus a negative 22. These minus a negative, they cancel each other out, so they create a positive or a plus sign. And now I'm going to add 6 plus 22, and I'm going to get 28 as my answer. Now we're going to solve the last one, which is negative 13 minus 5. And that's the same as saying negative 13 plus a negative 5. I see my signs are the same, so I'm going to add them together and keep that negative sign. I'm going to keep my negative, and 13 plus 5 is negative 18. So now I'm going to go down and look at the clues and see if I can figure out which student was matched up with which number. So this says Israel's missing number is 7 more than Delaney's missing number. So that one I don't really know quite yet, but let's see if we can get anything from the second clue. Brooke's missing number is positive. So when I look at all 3 solutions, I see there's only one that's positive here. So I'm going to write Brooke's name above this box. And now I know that Israel's and Delaney's are the 2 boxes that are left. So Israel's missing number is 7 more than Delaney's. Well, these are both negative numbers, and what we need to understand about negative numbers is whenever we're in the negative, whichever number is closer to 0 on the number line is the number that's greater. The farther away you get from 0 on the left or negative side of the number line, the smaller the number gets. So when I look at this, I have negative 18 and I have negative 25. Well, they are 7 integers or spaces apart, but the one that's greater is closer to 0. So this says Israel's missing number is 7 more than Delaney's missing number. So Israel's missing number is the one that's closer to 0, which is negative 18. And Delaney has the smallest number at negative 25. All right, let's look at our last two. Number 4 says, which expression has a value of negative 27? So to solve this, I just need to go through and I need to work out each problem and see which one gives me a value of negative 27. So here I have negative 16 minus a negative 11. My minus a negative becomes a positive, and this is negative 16 plus 11. Our signs are different, so I'm going to subtract and keep the sign of the greater magnitude, which is negative. So this one's going to be negative 5. Letter B is 19 minus 18, which is the same as saying 19 plus a negative 18. Again, my signs are different, so I'm going to subtract and keep the sign of the greater magnitude, which is positive. 19 minus 18 is 1. So far we haven't found anything with a value of negative 27. C is negative 13 minus 14. Rewriting that with the additive inverse is negative 13 plus a negative 14. Here my signs are the same, so I'm going to add and keep the sign. In this case, that's negative. 13 plus 14 is negative 27. Now let's look at choice D just to make sure we made the best choice. This says 25 minus a negative 2. I'm going to combine the two negatives, make this a plus sign, and 25 plus 2 equals a positive 27. So the only expression that had a value of negative 27 was C. And now we'll do the last one before you go ahead and get started on your homework. Number 5 says, which expression does not, this is important, circle that, does not have a value of 3. This means all the rest of these will have an answer of 3, and we're looking for the one that does not have that value. So negative 25 minus a negative 28, I'm going to combine those two negatives together and make them a plus. So this is really the same as saying negative 25 plus 28. My signs are different, so I'm going to subtract and keep the sign of the greater magnitude. In this case, it's positive. So 28 minus 25, that equals 3. But we're just going to keep on checking our work, looking for one that does not have a value of 3. 16 minus 13 is the same as saying 16 plus a negative 13. My signs are different, so I'm going to subtract and keep the sign of the greater magnitude. In this case, that's positive. So 16 minus 13 is 3. Still haven't found one without a value of 3. Let's look at choice C. I see negative 45 minus 42. So I rewrite this with the additive inverse property, and it is negative 45 plus a negative 42. I see that my signs are the same, so I'm going to add and keep the sign. So this is going to become negative 87. Well, that does not have a value of 3. So C is looking like a good choice, but we're always going to keep going and just continue to check our work. Negative 28 minus a negative 31. My minus and negative, we combine those two together, we merge them, and they become a plus. So now we have negative 28 plus 31. My signs are different, so I'm going to subtract and keep the sign of the greater magnitude. In this case, that's 31. So 31 minus 28, that equals 3. So I was right that choice C does not have a value of 3. So tonight for homework, you are going to be completing homework number 4. It says to work out each question, then look for the solution in the box down below for the letter, and then you're going to fill in the riddle to figure out, have you ever heard about the mathematical plant? And it's going to tell you a little fact about the mathematical plant. Great job today. Please bring in your homework so that I can check it.